Hello, and welcome to today's webinar. Today we are very excited to be joined by one of our newest people to our chromatography department, Mark Adams. Before we get started, I would like to remind you of a few things. If you happen to have any audio or video issues, please leave the webinar and rejoin. This oftentimes clears those issues. At the end, we will be answering questions. So please feel free to be submitting questions through the questions on GoToWebinar, and Mark will be happy to answer. If for some reason he does not respond to your question, he will answer via email. So with that, I would like to welcome Mark.
Welcome to this webinar today. The title of this talk is An Introduction to the Prep SFC for Medicinal Chemistry. My name is Mark Adams, and I'm a chromatography specialist here at Teledyne LABS. And the purpose of this talk is to give a brief overview of how Prep SFC can be used by medicinal chemists and incorporated into their workflow. So I'd like to begin by sharing a little bit about my own background because initially I was trained as a medicinal chemist. I did my graduate studies at the University of Pennsylvania with Professor Jeff Winkler, and I was working on the total synthesis of eleuthérobin. And after grad school, I moved over to San Diego, where I worked at a small biotech called Ligand Pharmaceuticals, where I was making small molecules which mimic the efficacy of steroids, such as prednisone, and this was for inflammation, cardiovascular disease, and oncology. But most of my time was spent at Takeda, San Diego. I worked almost 18 years at Takeda, and I worked in over a dozen drug discovery programs in oncology, inflammation, and neuroscience. And this included 2 clinical candidates, TAC 733 for oncology and CVN 424 for Parkinson's disease. So I feel I have a good understanding of the needs of medicinal chemists. And then in 2024, I moved over to Teledyne, where I currently work as a chromatography specialist, and my specialties include Prep SFC and Prep HPLC. Here's the outline for the webinar today and the topics I'll be discussing. First, what is supercritical fluid chromatography? Then I'll compare Prep SFC to Prep HPLC. I'll go over the similarities and differences. Then I'll discuss the benefits of Prep SFC and how it can make your life easier in the lab. I'll go over the Prep SFC workflow and how to integrate it into your own personal workflow. And finally, I'll discuss how to use the Prep SFC, and I'll go over the basic features of our system. Now, before I start the main part of the presentation, I think it helps to take a step back and see how Prep SFC fits into the big picture of the chromatography systems that you typically find in a medicinal chemistry lab. This slide shows the evolution of chromatography in medicinal chemistry. If you go back 20 years or so, the main method of purification in medicinal chemistry was flash chromatography, where you manually loaded the column. The process was labor-intensive in both loading the column and collecting the fractions. But with the widespread use of automated flash systems, everything became more efficient. The entire process was much faster, and it led to better separations since the columns were packed much tighter. Then, over time, reverse phase chromatography began to have a major role in medicinal chemistry labs. The technology evolved, and the purifications became easier to run than in the past. And Prep HPLC now allowed medicinal chemists to purify large libraries in a short amount of time. I believe the next phase in the evolution of chromatography is with Prep SFC. It is allowing chemists to become more efficient in the lab with faster runtimes and less solvent evaporation. Companies are now starting to have open access Prep SFCs in medicinal chemistry labs. What is supercritical CO2? CO2 exists in a variety of states. In the solid state, it is the dry ice in your rotovap. In the gas state, it's the bubbles in a can of soda. However, If you apply enough heat and pressure to CO2, it enters the supercritical state. Specifically, the temperature must be over 31 degrees Celsius and the pressure over 73 atm. If you look at the visual below, you can see CO2 as a gas and liquid phase. As you increase the pressure and temperature, you'll see the phases begin to merge, and after you pass the critical point of 31 degrees Celsius and 73 atm, CO2 enters the supercritical state, and you can see it is now homogeneous and no longer two separate phases. So why are we interested in supercritical CO2? Well, it's mainly due to the properties. It has both the properties of a gas and liquid. It has the gas-like properties of both a high diffusivity and low viscosity. Diffusivity is how quickly a substance spreads out, and the viscosity is the measure of the resistance to flow. So while the diffusivity and the viscosity is more gas-like, the density of supercritical CO2 is more liquid-like. Density is the mass per volume. Due to these properties, especially the low viscosity, it means that Prep SFC has a higher flow rate than Prep HPLC. And due to this higher flow rate, the Prep SFC purifications are typically 3 to 5 times faster than Prep HPLC. Also, the polarity of supercritical CO2 is similar to heptane, very nonpolar. However, it does have a higher solvating strength than heptane, meaning it can dissolve more things. I understand that the majority of medicinal chemists have little experience running Prep SFC. There can be some initial hesitation about learning to use the instrument due to its complexity or lack of experience. However, I try to explain to chemists that Prep SFC is just another type of chromatography and no more difficult to learn than flash chromatography or Prep HPLC. There can be a comparison made between flash chromatography and Prep SFC. Both are typically run in a normal phase mode. If you compare the solvents, flash chromatography often uses ethyl acetate as the B solvent and heptane as the A solvent. In Prep SFC, the B solvent would typically be methanol and the A solvent is supercritical CO2. Supercritical CO2 can be thought as just another mobile phase. Also, the technology of Prep SFC has greatly improved over the last 10 years, and the instrument is now very user-friendly. In order to get a better understanding of Prep SFC, it can be helpful to compare it to Prep HPLC. One of the main differences is Prep HPLC is usually done as reverse phase, and Prep SFC is typically normal phase. Also, the standard columns used are different. For Prep HPLC, C18 columns are the most common, and sometimes other columns are used, such as C8, C4, and PFP. However, Prep SFC does not have a standard column that is consistently used. There are a variety of columns to use including silica, 2EP, 4EP, PEI, and diol. Of these, I think that 2-ethylpyridine and 4-ethylpyridine are the most common. Now the run times and the amount of solvent used by a Prep HPLC can vary, yet on average, the Prep SFC will have a runtime that is 3 to 5 times faster than Prep HPLC and use between 60 to 90% less solvent than Prep HPLC. These are some of the benefits of Prep SFC, which I will discuss later in the presentation. The additives used for each are the same. The standard additives such as formic acid, TFA, ammonium bicarb can be used with Prep HPLC and Prep SFC. Then, turning attention to the software, on our Prep HPLC and Prep SFC, the software is the same. We use the same user-friendly touchscreen software. And finally, the size of each instrument is roughly the same. The Prep SFC is a little bigger than the Prep HPLC, but either can fit on a benchtop or in a large hood. This wasn't always the case, but the technology has improved, and the size of the Prep SFC has become much smaller. You may be wondering why you're just hearing about Prep SFC for medicinal chemistry now. Well, over the last 10 years, the technology has greatly improved. About 10 years ago, the Prep SFCs tended to be very large. Some of the systems were literally a wall of instrumentation. However, the newer ones have really come down in size, and they are now about the size of a Prep HPLC. In the past, the software tended to be difficult. You needed a very experienced analytical chemist to run the system. These days, the software is very user-friendly. On our system, we have an easy touchscreen software that can be taught in a short amount of time. Then, on older SFC systems, the collection options were often limited. It was typically large bottles. Now you can use an auto sampler, and you have the option to collect in test tubes, bottles, or even your own container. And in the past, Prep SFC was primarily used for chiral separations. However, things have changed, and now it is used for both chiral and achiral separations. It just depends on the needs of the project. Also, in the past, there was limited technical support for Prep SFC, meaning the amount of people who understood Prep SFC and did trainings were limited. These days, there are more people who use and understand Prep SFC. At Teledyne, all of our application scientists are trained on Prep SFC and available to help customers. Finally, 10 years ago, it would be rare to find an open access Prep SFC in a medicinal chemistry lab. Now it is becoming much more common, and I'm seeing more and more companies in the process of acquiring an open access Prep SFC for MedChem. There are many benefits in using Prep SFC. First, there is an annual cost savings in using Prep SFC compared to Prep HPLC. Then it is a green technology. You are not generating as much waste as other chromatography methods. Also, with Prep SFC, you are using up to 90% less solvent, and the runs are 3 to 5 times faster compared to Prep HPLC. Then, with Prep SFC, you are typically not using water, meaning you no longer have to evaporate water. You can also purify a wider range of compounds compared to Prep HPLC, and Prep SFC is complementary to Prep HPLC, meaning if you cannot separate a compound with Prep HPLC, you may be able to do it with Prep SFC. Finally, you need less flammable storage with Prep SFC. I've had experience in the lab when you ran out of flammable storage and we had to store the solvent off-site or even in the process lab. However, looking through the eyes of a medicinal chemist, I think several benefits really stand out. The idea of using up to 90% less solvent is very appealing, and you would no longer have to constantly refill your solvent containers and have less exposure to organic solvents. And the faster run times would save a lot of time. However, I think the benefit of not having to evaporate water would save the most time. You would not have to freeze dry your compounds anymore, and you could submit them on the same day. It is worth taking a closer look on how much time is actually saved. The amount of time you can save by not having to evaporate water will vary depending on your workflow, but in order to get an idea of the savings, I made some calculations based on my personal workflow experience when I worked in the lab. Typically, I would run a reaction, do a quick workup, then purify the crude material with HPLC. Then I would freeze dry the sample, which could take 1 or 2 days depending on the scale. Next, I would characterize the compound, transfer it to a submission vial, then finally dry it down again and submit the compound. On average, this process would take me approximately 2 to 3 days. On a typical week, I would purify about 3 compounds, and I know some weeks I wouldn't make any new compounds, and other weeks I would make a library. But on average, it was about 3 compounds a week. If you calculate the total number of compounds in a year, including vacations and holidays, it would give 144 compounds a year. These 144 compounds would take me at least 288 days to purify, with one day being the evaporation of water. If I purified these same compounds on Prep SFC, I could eliminate the water evaporation step and it would take me 144 days. It would take me half the time and I would save approximately 5 months. I know from experience that the competition towards a clinical candidate is fierce. The last project I worked on at Takeda was an NLRP3 inhibitor program. This isn't confidential information and there are published patents about the program. I did a quick Google search to see how many other companies had NLRP3 inhibitor programs, and it was more than 20 companies. There is a lot of competition for NLRP3 inhibitors. I remember I would check the new patents every Thursday to see if my current chemotype had been claimed. With Prep SFC, I could save 5 months of productivity. If you multiply these savings by all the bench chemists in a department, the savings are significant. It can make the difference between beating the competition towards a clinical candidate. As one of my supervisors used to always say, every second counts. In addition to the time savings with the Prep SFC, there is also an annual cost savings. While the price of a Prep SFC is more than a Prep HPLC, there can be a significant annual cost savings with the reduced solvent consumption. The Prep SFC uses up to 90% less solvent than a Prep HPLC, and the cost of methanol is less expensive than acetonitrile. Below is a table with the prices of the most common solvents for Prep HPLC and Prep SFC. According to Aldrich, the cost of a 4-liter bottle of acetonitrile for Prep HPLC is $470, while the price of a 4-liter bottle of methanol used for Prep SFC is $171, and for the cost of a 50-pound tank of CO2, Teledyne pays $19 per tank. Using these prices, you can make a rough calculation comparing the cost to purify a compound with Prep HPLC versus Prep SFC, with the assumption that you would use 90% less solvent than Prep SFC. The cost to purify the compound with Prep HPLC would be $470, and the cost with Prep SFC would be $72. This translates to an approximate 6-fold cost savings using Prep SFC for this specific example. There has been a variety of papers and companies who have studied the costs, and on average, you can expect to have a 2 to 5-fold cost savings for each compound you purify with Prep SFC over Prep HPLC. So depending on how much you use the instrument, the annual savings can be significant. I've explained some of the benefits of the Prep SFC, and now I would like to turn attention to the workflow. The workflow using the Prep SFC is very similar to Prep HPLC, and a comparison is made on this slide. The Prep HPLC workflow begins with the crude product after workup. Typically, once you have the crude product, the analytical screening is done using LCMS or UPLC. It is from this analytical screening where you can determine the purity of the desired product, and it can help determine the best method for the Prep HPLC. Once the purification is completed on the Prep HPLC, you typically have test tubes of acetonitrile and water. The next step would be to remove most of the acetonitrile and then evaporate the water, commonly done via freeze drying. And finally, you can characterize the compound and submit it. The workflow for Prep SFC is very similar to Prep HPLC. Once you have the crude product, the next step to do is the analytical screening. The difference is that for the Prep SFC, you are typically using an analytical SFC to help determine the best method for purification. Our Prep SFC system also has a tool called the Focus Gradient Generator, which can help determine the optimal method for purification. I will discuss this tool later in the presentation. After the analytical screening, The next step is to complete the purification with a Prep SFC, which is typically 3 to 5 times faster than Prep HPLC. Then instead of acetonitrile and water, you are just left with methanol to evaporate. And as I've mentioned before, the amount of solvent used for the Prep SFC is up to 90% less than with Prep HPLC. Then after evaporation, you can characterize the compound and submit it. Overall, the workflow is very similar for the Prep HPLC and Prep SFC, and there is a significant time savings with the Prep SFC by not having to evaporate water and faster run times. At this point, I would like to give a brief introduction to the Teledyne Acuprep SFC, and later I'll also provide some general instructions on how to use the instrument. These are some of the features of the Acuprep SFC. It can hold up to 6 columns, and these can be chiral or achiral columns. The columns are kept in a heated drawer in the instrument, which ensures the CO2 is always kept in a supercritical state. Then, the instrument can hold 4 different solvents, and the flow rate is between 50 to 200 mL a minute, and the maximum pressure is 6,000 psi, or 412 bar. Also, the co-solvent percentage range is between 5 and 70%. The co-solvent typically refers to methanol or the solvent you use with supercritical CO2. Most Prep SFCs on the market have a maximum co-solvent percentage of 40 to 50%, but ours can go up to 70%, which can be helpful if you are purifying a very polar compound. The instrument also has the focus gradient generator tool, which can help you determine the optimal method for purification. I will be discussing how to use this tool later in the presentation. Earlier in this presentation, I mentioned how the overall size of Prep SFCs have become smaller over time with advances in technology. The Acuprep SFC has one of the smallest footprints on the market compared to our competitors. On this slide, the green, blue, and orange boxes represents the sizes of Prep SFCs from some of our competitors. And this does not include the external computer and monitor, which is often required. Our system does not require an external computer or monitor. And with the cost of lab space these days, and all the instruments needed for a medicinal chemistry lab, the smaller footprint is very beneficial. I also wanted to take a moment to discuss the software we have on the Acuprep SFC. We use the same PeakTrak touchscreen software on the Acuprep SFC that we have in our CombiFlash flash chromatography system and our Acuprep HPLC system. If you have used either of these systems in the past, the learning curve will be very small or non-existent to begin running samples and using the Acuprep SFC. The software is the same, and you will find it's very easy to get started right away. In addition, we provide as much training as needed to make sure everyone in the lab is able to easily use the instrument. And our applications team is always available to answer any questions. So now I would like to show you how easy it is to submit a sample on the Acuprep SFC. If you were to walk up to the instrument with your sample ready, you would see this home screen. If you have ever used a Teledyne Acuprep HPLC, this screen will look very familiar. It's the same software and the home screen looks almost identical. To start your run, simply go to the column drop-down menu shown at the bottom of the screen. Then use the drop-down menu to select your desired column, and then move to the right to select your method. Typically, if you're using an open access instrument, you will select the default method, which is a good general method. At this point, if the default method is sufficient, you can go ahead and submit your sample and start your run. The entire process of submitting your sample is very user-friendly. Also, if you like to adjust the default method or create a method of your own, it's very easy. You can just go to the top of the screen and select the method editor, and it will take you to another screen to edit the method. So if you select the method editor at the top of the home screen, it will take you to this method editor screen. On this screen, you can easily adjust the gradient with a touch of your finger. It is very similar to adjusting the gradients on our Combi flash chromatography system or our Acuprep HPLC system. You can also edit the runtimes at the bottom of the screen. The runtime will depend on the method and the ease of purification, but I have seen some runtimes as short as 5 minutes. On the right of the screen, you can edit the peak detection, where you can choose the desired wavelength for UV detection. If you have the optional MS or ELSD on the instrument, you can configure the instrument to collect using mass or ELSD. You can also adjust the threshold for peak collection if the size of your sample is very small. On the upper right portion of the screen, you can edit the peak collection, whether to collect all the fractions or just the fractions with the peaks. You can also choose to collect no fractions if you're injecting small amounts for method development. When you are finished, you can exit and it will ask you if you want to save your changes. Select yes, and it will take you back to the home screen, and you can submit your sample and start your run. Now, if this instrument is used as an open access instrument, and there are a lot of users, you have the option to use the sample queue screen to submit your samples. This slide shows what the sample queue screen looks like. To get to the screen, all you need to do is press Edit Queue at the bottom of the screen on the home page. Once you are on the screen, it's easy to submit your sample. First, you touch the Add Row button to create a new row, then you enter the name of your sample, choose the desired column and method, and then enter the sample info and submit. And once you've submitted all your samples, you can simply walk away and come back later to retrieve your fractions. Also, if your sample is high priority, we have a priority option so your sample can jump ahead of the line and your sample will run much faster than the typical sample submission. We have heard very positive feedback from medicinal chemists who are using our open access Prep SFC in terms of ease of use. Typically, most of the methods you will use are already set up on the instrument, and you can just choose the method from the drop-down menu and submit your samples. Now, just to summarize, when submitting your sample, you can either go to the home screen or use the sample queue screen. The last few slides have been a basic overview showing these options. However, there are also a couple of other tools on the instrument I would like to describe, which you may find useful, and they can save you a lot of time with your purifications. The first tool in the Acuprep SFC I would like to present is the Focus Gradient Generator. This is a method development tool to help you determine the best method for an optimal separation. We have a lot of customers who consistently use this tool, and they have told us it saves a lot of time for method development. To use the Focus Gradient Generator, the process is first to set up a scout run, then you choose the desired peak to separate. After you choose the peak, the instrument will do a test run with the optimized gradient, and if the separation looks good, you can move forward with the separation. In order to get started, you simply go to the home screen, and instead of selecting the default method, you need to select Scout Run. A Scout Run is a quick 5-minute test run. After the run, it will display a chromatogram showing the peaks in your sample. The next step is to press the Focus Gradient button at the bottom of the screen, and a new window will pop up showing just the peaks in your sample. Then you can choose the peak you would like to separate via the touch screen and select Focus Range, which is how steep or shallow you want the gradient, and we also have an isocratic option that you can choose. After these selections are made, press Focus and it'll go back to the home screen and you can submit your sample. It will then start a run using a new optimized method with a goal of baseline separation. After the run is complete, it will display a chromatogram using this new method, and if the separation fits your needs, you can move forward with the separation. On this slide, you can see the baseline separation on the chromatogram after the focus gradient tool was used. The chromatogram before the focus gradient tool show little to no baseline separation. At this point, if you're happy with the separation, you can move forward and purify your sample with this new optimized method. And there is also another feature we have on the instrument that can save you time with your purification. We have the option to use stacked injections. I think most analytical chemists are very familiar running stacked injections. However, I know medicinal chemists have less experience using this tool. I think a little background about stacked injections may be helpful. If you look at the chromatogram at the bottom, the run time is the total duration of the run, and the actual time when your peaks come off is called the cycle time. And you also have a delay time, which is the time leading up to the cycle time. Stacked injections is a process of injecting your sample continuously so that the cycle time is repeated and you eliminate the delay time. This process will drastically reduce the time it takes to purify a sample. And on a side note, stacked injections are very useful, but can only be done using the isocratic method, and typically the sample can't have too many impurity peaks far away from the desired peak. Otherwise, these impurities would overlap with the next injection. To run the stacked injection tool, simply press the Stacked Injections button at the bottom of the screen to begin. This slide shows the window that appears after you press the Stack Injections button. It will show a simulation of the first 3 injections, and at this point, you can easily adjust the cycle times and peak windows. You can manually increase or decrease the time between each run to optimize the separation. Then after the adjustments are made, you can then enter the amount of sample you would like to inject and start the run. And you can continue to edit this run at any point during the purification, as long as you are not on the last run. On the right-hand side of this slide, you can see the chromatogram of the completed separation. For this specific sample using stacked injections, 6 injections were completed that took approximately 9 minutes. If these 9 injections were done with a single injection at a time, it would have taken approximately 30 minutes. It is greater than a 3-fold time savings using stacked injections. For a medicinal chemist, I think this tool will be very helpful if you are scaling up a final compound or an important intermediate. At this point, I would like to summarize some of the benefits of Prep SFC for medicinal chemistry. First, with Prep SFC, you're using up to 90% less solvent than you would with Prep HPLC. This means fewer solvent refills and less exposure to toxic solvents. Also, the solvent costs are much lower than Prep HPLC. Second, you don't have to evaporate water at the end. Typically, the final solvent is methanol, and you can just concentrate the solvent and move on to characterize your compound. I often encourage chemists to look back on their own workflow in the lab and calculate how much time could be saved by eliminating the water evaporation step. In my case, I would be saving 5 months. Third, the run times are faster, usually 3 to 5 times faster than Prep HPLC, and this time will add up. If the Prep SFC is consistently used, you will soon be submitting compounds faster and spending less time on purifications. And the time saved will become more apparent during scale-ups and tight separations when you have a lot of injections. Finally, there is the benefit of ease of use of our instrument. Our Prep SFC is very user-friendly. If you have used our flash chromatography or Prep HPLC systems, you will find the learning curve to use the Prep SFC is very small, and our applications team will be there to help you at any time. Now, before I finish this presentation, I wanted to have at least one slide that talks about CO2 infrastructure. This is a common question we get when people are interested in Prep SFC. These days, most larger companies have in-house CO2, typically using a bulk tank and sometimes large dewars. In these cases, CO2 supply is never an issue. Typically, facility works with the gas supplier to ensure the tanks are always filled. For companies that do not have in-house CO2, there are many options, and there is not a one-size-fits-all solution. Many companies choose to use 50-pound CO2 tanks. We have a CO2 manifold that we can install for customers that holds 4 tanks, and you can use 2 tanks at a time. You simply replace the 2 empty tanks after you switch to the new ones. And I have visited some companies that use 8 tanks for their Prep SFC. The number of tanks that are needed is dependent on the use of the instrument and scale of separations. We can help guide you along the way to make sure you have adequate CO2 supply. And there are other options besides using 50-pound tanks, such as using dewars with a booster pump. Now, to run the instrument, you typically need the CO2 pressure to be above 700 psi. The 50-pound tanks are about 800 psi at room temperature, and bulk tanks and dewars are around 300 psi. In order to increase the pressure of the CO2 from the bulk tanks and dewars, you need to install a booster pump to maintain the desired pressure. And with a booster pump, you can have the tank anywhere in the building, and a CO2 line can be installed into your lab. If you have any questions about CO2 supply, please don't hesitate to contact our team. We have a lot of experience helping customers. We also have another webinar on the topic. So I want to thank you for your time and attending this webinar. This is a picture of our applications team. I'm the first person to the right of the instrument. All of our applications scientists are trained in Prep SFC, and our job is to help you. We offer support at all stages of a Prep SFC acquisition. If you are new to Prep SFC and want to know how things work, we're here to help. If you need training once you have the instrument, we will be there to help. And if you have any Prep SC related questions about purification or using the instrument, you can contact us at any time. I get emails and text messages on a regular basis, and I try to get back to everyone on the same day. I worked as a bench chemist for a long time, and I understand the importance of optimizing your purification and having questions answered as soon as possible. Also, we are constantly making improvements and updates to the instrument. These improvements are based on customer feedback. We make it a point to listen to our customers and make improvements to fit their needs. On the links below, you can find out more information about the Acuprep SFC instrument, and we also have a blog where we post about ways to help you with your purifications, whether it's flash chromatography, Prep HPLC, or Prep SFC. And here's my email. Please feel free to reach out to me if you have any questions. And you can also find us under Teledyne LABS on Facebook, X, LinkedIn, and YouTube. So at this time, I'd be happy to take any questions that you may have. I know we already have some questions which have been submitted, so I'd like to go through some of these questions. So the first one is, when I consider which techniques to use, what type of compounds might be better suited for HPLC? This is an excellent question, I think. So the question is, when should I use Prep HPLC over Prep SFC? Just from my own experience at Takeda, I worked on a lot of different compounds, and I found that any compound that I could purify with Prep SFC, I could also purify with Prep HPLC. It was just a matter of deciding which one I wanted to use. And in my case, I didn't get a good separation with Prep HPLC, so I was using a lot of Prep SFC. And it also depends on how available is the SFC for you. Do you have an open access Prep SFC? So a lot of it's just deciding which one you want to use. But I would say for normal drug-like small molecules that you typically find in a medicinal chemistry project, you can purify most of them by either Prep HPLC or Prep SFC. But back to the original questions, which ones are better for Prep HPLC? I would say if your compounds are very polar or aqueous soluble, I think Prep HPLC would be better. And these often include higher weight molecules like peptides. And there is a lot of work going on at universities and at companies looking for ways to purify peptides and even oligonucleotides on Prep SFC. And they're having some success, but I think a lot more work is needed to be done before it's widely accepted in the lab. So yeah, it's a really good question. Okay, so the next one is, can I use DMSO to dissolve samples for open access Prep SFC like an HPLC? Can I use DMSO to dissolve my sample? The short answer is yes, but there are some things to keep in mind. DMSO tends to be retained a bit on the SFC depending on the stationary phase, so it's just something to keep in mind. And as you know, DMSO dissolves everything. So I would add a little bit of your co-solvent, like methanol, maybe like a ml to your sample, just to make sure that nothing crashes out, because the last thing you want is things to start crashing out in your column. So just make sure there's no solubility issues. But personally, DMSO would not be my first choice just for the fact that it dissolves everything. I think I would prefer methanol over DMSO if possible. Okay, so the next question is, can I run crude samples on Prep SFC? So you can, but as a general rule, I would not recommend it. So in a minimum, I would do a quick workup on your sample. So when you're asking about a crude sample, I'm assuming this means after you do your reaction, you just concentrate it down, then dissolve it in a solvent like methanol, and then load it directly onto your Prep SFC. So I would say at minimum do a quick workup. I know when I was working in the lab and I had a library and I was using like 4 ml vials and I had a lot of reactions to do for a workup, I would just add a ml of brine and a ml of ethyl acetate. I'd put the cap on and shake it, then just use a pipette to get the organic phase. I'd filter that and load that directly onto the column for just a really quick workup. But if you have a larger scale and there's a lot of salts, a lot of metals, if you have a big Suzuki reaction, I would definitely do a quick workup and try to do a really quick column just to clean up the junk, or at minimum even filter it through sea light because you just don't want that stuff on the column. And that being said, I know chemists still load crude samples onto the Prep SFC. I've seen this happening at companies. And what it means is it's just more work for the super user or the person in charge of the instrument. It's going to be more swapping out guard columns. It's going to be fixing clogs. It's going to be flushing columns. So it's just a lot more work, and it's going to shorten the life of your column. So if possible, I would not load the crude sample on your Prep SFC or even your Prep HPLC. Okay, I'll take a couple more questions. So here's one. What are the recovery rates of Prep SFC? So in generally, the recovery rates are very good. I would say in general, it's greater than 95%. We've done a lot of internal studies looking at this number, and it's fairly consistent with what our customers tell us. And there are several factors that go into what makes the recovery excellent. A lot of this has to do with the hardware. I mean, there's something called a BPR or back pressure regulator, which controls the pressure. There's the gas liquid separator, which removes the CO2 from the solvent at the end. There's the makeup pump, which adds additional solvent when needed so your compound doesn't crash out. So it's a lot of these little things that add up to make an excellent recovery. So for ours, definitely greater than 95%. And I'll answer one more question. So it says, here's one. Can you do stacked injections on the Prep HPLC? So I went over in the webinar stacked injections for the Prep SFC. And yes, if you use our Teledyne Acuprep HPLC, you can definitely do stacked injections with the HPLC. I would just make sure you have the latest update. We just added that feature with the latest update for the HPLC. And if you need help, if you've never done stacked injections, we have guides on our website. We actually have webinars on stacked injections. So just go to YouTube and look under Teledyne LABS. And if you still need help, feel free to contact me and I can try to help you as best I can, either through email, and if you're local, I can stop by, or another Teledyne representative can stop by. My email again is mark.adams02@teledyne.com. So I think I'll end it here. So again, I just wanted to thank you for attending this webinar, and feel free to contact me or us at any time. Thank you.